Hello, this is Ben here, and today we're going to talk about one of the most important concepts of math that we learn right in around 6th grade, and that is that you can't divide by zero, right? So in math, you can't divide by zero, or if you have zero on the bottom of a fraction in the denominator position, it's undefined. You can't do it. But I'm going to do something that's kind of crazy, and I'm going to prove to you that 1 equals 2 only if you can divide by zero, which you can't do. So that ultimately is why you can't divide by zero. Because if you could prove crazy things like 1 equals 2 and all kinds of things like that. So I'm going to do a proof that's going to show that 1 equals 2. And the reason why the proof doesn't work is I want you to try to figure that out. Why doesn't the proof work? So we're going to begin by setting x equal to y, which I can do. I can set x equal to y, no problem with that. Then we're going to multiply both sides by x. So multiply the left side by x, you get x times x, which is x squared. Multiply the right side by x, you get x times y, which is xy. Okay, then we're going to subtract y squared from both sides. So now we get x squared minus y squared equals xy minus y squared. Okay, not a problem. So far, everything I've done is legitimate. I'm just doing the same thing to both sides, which is perfectly fine. What you do to one side, you got to do to the other side. Golden rule of solving equations. All right, next thing I'm going to do is I'm going to factor. So now we're going to factor this, and this factors 2x squared minus y squared. That's a difference of perfect squares. So x plus y times x minus y. Okay, factoring this side, we simply pull out the common x or common y. They both have a y. So we factor out the GCF, so we get y times x minus y. Okay, no problem with that. Factoring is perfectly fine. Now, they both have an x minus y on each side. They both have that as a factor, so that can cancel. I'm going to switch to this side so you get to see the whole board here. So the x minus y's cancel. Now we have x plus y equals y. Well, that looks kind of crazy, but that's what you get. Okay, well, we set x equal to y initially, so we can use basic substitution now and substitute a y in for this x. So now we have y plus y equals y. Okay, collect like terms on this side. You get 2y equals y. And now divide both sides by y. And you get that 2 is equal to 1. All right, so there we go. So the question is, what's wrong with this proof? Which step is wrong? And actually, the step that is wrong is right here, when you cancel out the x minus y's. Why is that wrong? Well, let's look at this. When we set x equal to y, that means x and y are the same. So what does x minus y equal? X minus y has to equal 0 because x and y are the same. So when we canceled this out, we divided both sides by 0 because that's how we cancel something out. So we divided both sides by 0, which is a problem. So that's why right here this proof doesn't work, and that's essentially why you can't divide by 0. So if you could divide by 0, then think about it. 2 times 0 equals 3 times 0. That's correct, okay? But if you cancel out the zeros, you can't say that 2 equals 3, right? That doesn't work. So 0 does equal 0 here, but 2 certainly doesn't equal 3. So that's a problem. So that's why you can't divide by 0, because then you could prove crazy things like 1 equals 2. Thank you, and have a great day.